Hello, in this video I will show you how to expand complex numbers. So complex numbers is summed up as just the use of I. So as you can tell in this equation, we have 3 plus 7i times 8 plus 2i. And I stands for imaginary number. Imaginary number. And basically, I, of course, has a value. I is equal to square root of negative 1. Now, square root of negative 1 is obviously not possible. You can't square root a negative, and on top of that, you can't square root 1. So that's an imaginary number. But here's one thing that we must establish before we actually take a look at this equation. I is equal to square root of negative 1, right? And that means that we have another possible solution. That means that I squared is just equal to square root of negative 1 multiplied by square root of negative 1. So that means the square roots simply cancel out, which means that I squared is equal to negative 1. Now, this will come in handy once we have expanded this equation here. Now, we will be using the FOIL method because we are just expanding as if we were expanding a normal quadratic equation that has been factored. So we're just making this from factored form into standard form. It's basically all we're doing. Now, if you're familiar with the FOIL method, you know that we have to multiply whatever is in these first brackets by everything that's in the second brackets. So we'll do 3 times 8 as our first multiplication. So 3 times 8, 24. So now we have 24 here. Next, we have to do 3 times 2i right there. So we're just going to treat I as if it's x when expanding. So 3 times 2i is 6i, right? So plus 6i. And then we take 7i times 8. 7i times 8 plus 56i. And 7i times positive 2i is equal to positive 14i squared. Because remember, 7i and 2i both have i's in it. And when you multiply I times I, that becomes I squared. Right? And then you just 7 times 2, 14, 14i squared. So now we have our complete equation here. So let's take a look at this one more time. So this is just a normal standard equation. And how can we simplify this even further? We'll take this and we can make this into 24 plus 6i plus 56i are like numbers, so we can combine them. 6i plus 56i is going to be 62i plus 14i squared. Now, you may think that this is our solution, but hold on. Remember that in the beginning, we had established that I is equal to square root of negative I, and I squared was equal to negative 1. What number in this equation here can we possibly plug one of these values in and break it down even further? We can't break down I. We can't break down 62i, because remember, square root of negative 1 is an impossible number. You can't change that. But I squared is a real number. Negative 1 is a number that we can actually plug in. So let's go ahead and do that. So we've got 24 plus 62i plus 14 times what's I squared? Negative 1. squared is negative 1 times negative 1. Now that just becomes 24 plus 62i minus 14. And this is just a matter of simple simplification, where it's just, this becomes 24 minus 14 is 10 plus 62i. And this is going to be your final answer. And oftentimes in the problem, you'll see the question ask for this equation in terms of a plus bi. And all that is that it's this equation, but you have to write it in 10 plus 62i. You can't write 62i plus 10. So you want to be careful of that. And if it ever asks you on what the a or b values are, you're obviously just going to leave out the I. So a would be equal to 10, b would be equal to 62. So that's a type of problem that could come on your test. So just be careful of that. And it's a pretty simple method. You just have to be careful of how you treat the I, and make sure that you simplify this quadratic equation